Hello again and welcome to the course Mechanics and Heat. Today we're going to start with chapter 2, motion in one dimension. Let's start by defining motion. We can define motion as the change of position with time. If we look around us, everything is moving. We can see cars moving, people moving. If we kick a ball, it's going to move in a certain direction. Everything is moving. The earth itself is moving. The moon is always moving. Everything is moving in different directions and different speeds. So basically, if we want to define physics, for the most part of it, it's going to be the study of motion. In kinematics, we're going to describe motion. That's the first part of our course. In the second part of the course, which is dynamics, we're going to look at forces and how we're going to see how they affect motion. So what is moving and how is moving though depend on where we stand. So it depends on our perspective. So in order to describe motion, we need a reference. Motion is always relative. So what is moving with respect to me might not be moving with respect to something else. Let's take an example. If we're sitting in the car, the person sitting next to you is not moving with respect to you. However, with respect to someone standing outside the car, both of you are moving with the car. Same, for example, if we are studying the motion of the moon here from Earth, we consider ourselves as fixed and the moon is rotating around the Earth. However, if we're looking at with respect to the sun, both the moon and the Earth are moving. So whenever we want to study motion, the first thing we need to choose is our reference. We're going to ask ourselves, moving with respect to what? A reference or a frame of reference is a point that we assume to be fixed, relative to which all positions are measured. And if this position is changing in time, then we have motion. Okay, so now what to do in a physics problem? How to tackle a physics problem? What is the strategy that we're going to use to tackle a physics problem? We said that for the most part of it, the physics is a study of objects in motion. So the first step we want to do in any problem or in any project that we are doing or any exercise is we want to specify the object that we are studying, the object that is moving or tend to move. What is our object? For example, if I'm looking on the street, my object could be the cars. It could be the moon. If I want to study the motion of the moon around the Earth, it could be the Earth itself. It could be the whole solar system. So I want to specify what object I'm studying. The second step is I want to choose my reference point or the origin. This point is the point that I'm assuming fixed, and every position I'm measuring with respect to it. The choice of the reference point is arbitrary. I can choose any point I want. So for example, if I'm in a room and I want to study my own motion, so I'm walking around in a room. So imagine you stand up, you walk back and forth in the room. You want to study your own motion or you want to study your position. So you want to take a reference in the room that is not moving with you. So I can take the corner of the room, one of the corners of the room, as my reference. So at each time, I would measure my position relative to that point. The third step, in order to measure position, I need to choose directions or axes, what I call positive and what I call negative. Again, those are choices of mine. Those are arbitrary choices. But however, whenever I choose my axes or origin, I have to stick with them in order to be consistent in the whole problem. So I would choose one wall, for example, as the x-axis and one wall as the y-axis. And then I could be moving along the x-axis, I could be moving along the y-axis, or any combination of both. I could be moving in the positive x direction if I'm moving in the chosen positive direction. I could be moving in the negative x direction. The fourth step is I want to choose the unit in which I'm measuring distance and time. So in order to measure distance, I could use meter, centimeter, or I could use any arbitrary unit that specify distance. So for example, in a room, I could use the tiles as my unit. Also, I need a unit for time as well. So usually the standard units are meter for distance and second for time. The combination of the origin axis and this scale, I call them my coordinate system. And all these are choices, these are arbitrary choices, these are artifacts that I'm using to describe the physical world. What really happens in the world does not depend on my system. So if I choose a different origin or a different scale or unit, that should not change what really happening. It might change a little bit how I'm describing it, but it will not change what it really happened in the real physics world. And I should be able to switch from one description to another. So if I'm describing things, for example, as simple as that as distance in meter, if I change this to a distance in kilometer, the real distance did not change. What changed is the value that I'm describing, but it's still describing the same physical quantity. Okay, so here are some examples of the coordinate systems that I chose, that I can choose. So for example, if I have two balls moving in a plane, I could choose the corner as my origin here, and then I would choose the x-axis along one of the lines and the y-axis along the other line. Then the motion of the coordinate system, the balls are described by two coordinates, x and y. If I'm kicking a ball vertically and horizontally as well, so I'm kicking it in horizontal and vertical position, I can describe the vertical position by the y-axis and the horizontal position by the x-axis, and the origin point would be where the ball started, and then I can also describe it by x and y. If I'm going down a slide, I could also still choose x-axis horizontal and y-axis vertical, but then if I choose the x-axis down the slope itself, I actually make my calculation much easier, because now I have motion only in the one axis. So even though the choice of the coordinate system does not affect the physics, a well-chosen coordinate system might simplify my equations, my mathematical equations, and make my life easier. So a good rule of thumb is to choose one of the axes in the direction of motion if I know the direction of motion. So here, if I'm going down a slope, I could choose the x-axis down the slope. So then the motion is going to be described by one axis. Here with the ball, I could not do that because I don't have motion in a straight line, so I have a parabola being traced by the ball. I have to choose two axes. Okay, so let's focus now on one dimension. So if I have motion in one dimension, so I have the one sliding on the slope or moving horizontally, so I have to focus on motion in one dimension. So I have the origin point. I have my origin point here, and then I have the object that I'm studying. So I specified the object that I'm studying first. I chose my origin point. I chose the x-axis in the direction of motion. The position of the object at any time t is described by the value of x. X could be positive if I'm on the right side of the origin, or negative if I'm on the left side of the origin. However, as we said, motion involves the change in position, not position itself. So I don't care about the exact position, I care about the change in position. So I'm going to define the displacement. The displacement is the change in position, and it's called delta x. Anything that we have changed, now we're going to use the symbol delta, the Greek letter delta, to describe. So the change in position is going to be described by delta x. So if the object was at x initial here, and then it moved to x final, there is a change in the displacement delta x, and delta x is x final minus x0 or x initial. Delta x could be positive or negative. If I'm moving in the positive x direction, so I'm moving forward if you want, that's delta x is going to end up as positive because x final is going to be larger than x initial. If I'm moving in the negative x direction, x final is going to be less than x initial, and I have negative displacement. Okay, here is an example of the displacement and intervals that I have to define. So we have a person that starts here at x1 at 0, and then you walk to a friend's house where x is equal to 60 meters. Then from the friend's house you go to the video store, which is at x3 equal to 160 meters. then you go back to the friend's house. In the first interval, if we look here at the table, we go from x1 to x2. So the displacement delta x1 is x2 minus x1, and this would be plus 60 meters. Then in the second interval, so you see every time I'm defining a displacement, I'm defining it in an interval. So I have to have initial time and final time, or initial position and final position. So I'm defining it in an interval. So x2, I went from in the second interval, I went from x2 to x3. So I got my displacement delta x2 as x3 minus x2, which gives me plus 200 meter. In the third interval, I went from x3 back to my friend's house, so to x2. So this is x2 minus x3. So now x2 is the final and x3 is the initial, and the displacement is minus 200 meters. Now, I also could look at the total interval, the final interval. So I could look at the whole displacement. So delta x4, or the fourth displacement, is actually x2 minus x1. So it's my final position, x2, because I ended up at my friend's house, which is at x2, and my initial position, which was my own house, x1, and this gives me a total displacement of 60 meters. Another way to calculate the total displacement is to add all the intervals inside this total displacement. So I could say that I go from delta x1, then delta x2, then I add delta x3, and this should give me delta x4, which should give me the exact same answer, 40 meters. So the displacement only depends on the initial and the final position of the moving object, not on the trajectory that I followed in between. And since the displacement you see here, since the displacement depends on the difference of position, it does not depend on the choice of the origin. So you see, the choice of the origin, even though it's important to define the position, it's not going to play a role in the displacement, which is what we care about when we talk about in motion. So the displacement, as we said, could be positive or negative, depend on which direction I'm moving. So the sign of the displacement determine the direction of motion, or vice versa. However, there is something else we need to distinguish, is what we call the net distance traveled. The net distance traveled is not exactly the displacement. So you see, the displacement only depends on the initial and the final position. It does not depend on what happens in between. However, for example, if I want to do an exercise, I would go around a playground. I come back to my original position. So my net displacement is 0. However, I did something, and I sometimes care about this stuff that I did, because if I want to exercise, I care about what is the total distance I traveled. So the total distance, I could define it as the total travel distance, and I could have it as the sum of the absolute value of the displacement. If the displacement is always in one direction, then d is going to be the absolute value of the total displacement. But if I have displacement in different directions, then I have to take each interval alone, change them to positive, and then add them to get the total distance traveled. So the total distance traveled is always larger or equal than the displacement, the absolute value of the displacement. Of course, the total distance traveled, it doesn't make sense to define it as positive or negative, because it does not have direction. It could be in any direction. I'm just adding distances. Now, another thing, the most important thing about motion is to define velocity. So we're going to start by defining the average velocity. So when an object moves from initial position to a final position, it's going to have a displacement. The velocity is the rate of change of position. So how fast we did this displacement. That's basically what is the average velocity. And I'm going to define it as an average velocity, because I'm just going to talk about the initial and the final position. I'm not going to care about what's happening in the middle. So I'm going to find the average velocity, Vx. The underscore x indicate that this is the velocity in the x direction. Here we're working only in one direction, so we care about only one velocity. But later on, we're going to see that we have different velocities for different directions. Also, we're going to put this bar on top of it. This bar indicates that we're talking about an average. So it is the displacement over the time it took to do this displacement. So delta t is t2 minus t1. So the average velocity Vx has the same sign as the displacement, since delta t is always positive. So Vx also tell us about the direction of the displacement. If Vx is positive, then the displacement is in the positive direction. If Vx is negative, then the displacement is in the negative direction. If delta x is 0, then the average velocity is also 0. This doesn't mean that we didn't have any motion. It means that we ended up in the same position. We could be stationary in the same position all the time, or we could have walked forward and then backward to the same original position, and this is gonna end up in a 0 position. Now, Vx average is a quantity over an interval, so it's also like the displacement. So we have to have initial and final position, or initial and final time. Now we see from the definition of the velocity that it has the dimensions of distance over time. So in the standard units, the unit of velocity is gonna be meter over second. Of course, we could use different distance and time units to define the velocity. Sometimes we use kilometer per hour or mile per hour. We have to distinguish between the average velocity, which we care about in physics, and the average speed. The average speed, so if we went back to the same position, the displacement is going to be 0, the average velocity is going to be 0, but we had a speed. For example, if we're running around a playground, we had a speed, and then we can define our speed as, or the average speed as, the net distance traveled over delta t. And of course, we're going to always end up with an average speed larger or equal than the average velocity. Okay, let's go back to the example that we talked about before. So let's consider 3 intervals. You walk from your house to the store directly, so from x1 to x3, and it took you 3 minutes and 20 seconds to get to the store. You spend in the store, we'll assume that you're stationary in the store for 5 minutes, and then you go back from the store to your friend's house in 2 minutes and 5 seconds. Let's look at each interval alone, find the average velocity and the speed of each interval, and then we look at the total trip as a whole. So in the first interval, we go from x1 to x3, and delta x of this interval is 260 meters. So it's x3 minus x1. The time it took is 3 minutes and 20 seconds, so we change it to a unit that we can use in calculation. Let's choose seconds, so we change it to seconds. That gives us 200 seconds. Remember, each minute is a 60 second. Then for the average velocity, we have the displacement, the net displacement of this interval over time. So you see, for each interval, I'm defining the average velocity, and we got 1.3 meter per second. The average speed here is the same because I don't have a difference. I'm moving in one direction, so I don't have a difference between the speed and the velocity. In the second interval, I'm not moving. So delta x2 is 0. And the time is 300 seconds, so the average velocity is 0, and the average speed is 0. We're ignoring any motion you do inside the store. In the second displacement, third part of the trip, I go from the store back to my friend's house, so from x3 to x2. So the displacement is x2 minus x3, which gives me minus 200 meters. The time it took me to do that is 125 seconds. So the average velocity is minus 200 meters over 125 seconds. So I got minus 1.6 meter per second. The average speed is just, again, since I'm moving in one direction, the average speed is just the absolute value of the displacement over time. So I got 1.6 meter per second. If I look at the total displacement, so totally I went from x1 to x2. So my net displacement is 60 meters. But the total distance traveled is not 60 meters because I went 260 forward and then I went 200 backward. So I have to add their absolute values. So my net displacement is 60, but the net distance traveled is 460 meters. The time, I just add time. Time is always additive, it's always positive. So my net time interval is 625 seconds. So my average velocity is 0.1 meter per second. However, my average speed is 0.73 meter per second, which obviously is larger than the average velocity, the absolute value of the average velocity. Okay, I'm gonna conclude my video here now, and then I will, in the next video, I will talk about instantaneous velocity. Please let me know if you have any questions, any comments on the videos, on the quality of the videos, and hopefully we will gonna have a fruitful lectures. Thank you.